Hi, I'm continuing from this 14th slide. Need for transaction status and intelligence links in a recovery file. Some recovery managers have decided to write the objects, assuming that the transactions normally commit. If transactions is a larger number of bigger objects, then contiguously to the recovery file may complicate the design of server. In the timestamp ordering concurrency, transaction will eventually be commit and acknowledges the client. During this time, the objects are returned to the recovery file to ensure their performance. However, in such situation, the corresponding transaction state enters in the recovery file and will be waiting to commit and then committed to ensure the timestamp. In the next slide, recovery of two-phase commit protocol. In this distributed transaction, each server kept its own recovery file, and the recovery managers use two new status values for this purpose, though they are done and uncertain. A coordinator uses committed to indicate that the outcome of the vote is yes, and a participant uses uncertain to indicate that it has voted yes but does not know the outcome to be outcome of the vote. Type of entry: coordinator, and description of contents of entry. Transaction identifier: list of participants, and the participant transaction identifier coordinator. The next one, recovery of two-phase commit protocol. In phase 1 of the protocol, when the coordinator is prepared to commit, as it must have already prepared to commit. When it votes yes, its recovery manager records a participant entry and adds an uncertain transaction. In the phase 2 of this protocol, the recovery manager adds either a committed or an aborted transaction status to its recovery file, and the recovery manager of the participants add a decision, and this must be forced right, and this need to be forced. The done status entry is not a part of the protocol, but it is used when the recovery file is reorganized. The next one, continuing, the figure entries in a log of transaction T in which the server played the coordinator role, and for transaction U in which the server played the transaction role. For both transactions, the prepared transaction status entry comes first. In a case of coordinator, it is followed by a coordinator entry, uncommitted transaction status entry. This uncertain and then committed about a transaction entry. On the next one, slide, maybe the continuation is forgotten. Coordinator prepare, and we can see the action of the recovery manager, and if it is participant prepare the status, then the participant has not yet voted and can abort the transaction. So we can see here, and the nested transactions. For example, suppose the transactions are shown in the figure T1, T11, T12 and T2 all access the same object. See, you can see there object A in the order T1, T12, T11, T11, T12 and T2. Suppose that their intended versions are called A1, A11, A12 and A2. When T1 starts executing, here you can see A1 is based on the committed versions of A, and it is pushed onto the stack. When T11 starts executing, it bases its version A11 on A1 and pushes it onto the stack. When it completes, it replaces its parent version on the stack. The transaction T12 and T2 act in a similar way, finally leaving the result of T12 at the top of the stack. Next, the conclusion. Transaction-based applications have strong requirements for the long life and integrity of the information stored, but they do not usually have requirements for immediate response at all times. Atomic commit protocols are the key to distributed transactions, but they cannot be guaranteed to complete within a particular time limit. That's users of a transaction service will experience some delay during recovery, although it's assumed that the servers of distributed transactions exhibit crash failure and run in an asynchronous system. And these references for this.